Dears, welcome in the Education Department at SHAHD Association. Our lesson today is about covalent bond. Make sure to subscribe to our channel for more lessons. And don't forget to activate the bell to stay notified. In this lesson, we will explain the covalent bond formation. We will write Lewis dot structure. Before we start our lesson, let's make a simple review. The valence shell. The valence shell is the last filled shell. The valence electrons, they are the electrons in the outer shell. The valence is the number of electrons that are needed to satisfy octet and duet rule. These rules apply when electrons are lost, gained, or shared. In the previous time, we talked about the ionic bond. In the Explore section, we made a simple review about the ionic bond and we said that it occurs between metals and nonmetals. Today, we will take a new bond. It's called the covalent bond. The covalent bond is the bond that occurs between two nonmetals. In this type of bond, we have sharing of electrons. The two nonmetals tend to bond together by sharing the unpaired electrons. In this type of bond, we have three types: the single covalent bond, the double covalent bond, and the triple covalent bond. Let's take the first case when we have a single covalent bond. In this type of bond, we have sharing of two electrons, or we say that we have sharing of one pair of electrons. So each atom provides one electron. Let's do the following example. If we have the compound Cl2, it occurs between two chlorine atoms. Let's first make the electron configuration of chlorine. K2, L8, M7. From this electron configuration, we can tell that chlorine is in group 7. It is non-metal. So each chlorine atom needs one electron to satisfy octet rule. In this case, each chlorine atom shares one electron to be stable. So we write the Lewis symbol of chlorine. One electron is moved from the left chlorine, and also one electron is moved from the right chlorine. These shared electrons form a bond which is the single covalent bond. This is the Lewis dot structure. Let's take the second case when we have double covalent bond. In this type of bond, we have sharing of 4 electrons, or 2 pairs of electrons. So each atom provides 2 electrons, like in the example of O2. Let's make the electron configuration of oxygen. So it's K2, L6. From this electron configuration, we can tell that oxygen is in group 6. It is non-metal. So each oxygen atom needs 2 electrons to satisfy octet rule. In this case, each oxygen atom shares 2 electrons. So we write the Lewis symbol and surrounded by 6 dots. Each oxygen shares 2 electrons. These 2 electrons make double covalent bond and we get the Lewis dot structure. The final case when we have triple covalent bond. In this type of bond, we have sharing of 6 electrons, or 3 pairs of electrons. So each atom provides 3 electrons, like in the example of N2. This is the electron configuration of nitrogen, K2-Al5. From this electron configuration, we can tell that nitrogen is in group 5 because the valence electron is 5. It is non-metal. So each nitrogen needs 3 electrons. So each nitrogen shares 3 electrons to satisfy octet rule. We write the Lewis symbol of each nitrogen atom surrounded by 5 dots. So each nitrogen shares 3 electrons, and these 3 electrons make a bond which is the triple covalent bond, and this is the Lewis dot structure. Thanks for watching. If you liked this lesson, make sure to subscribe to our channel for more. And don't forget to click the bell to get all the updates.